Hey Wildcats, so this is Unit 7 focus question number 1 when we're looking at vectors in 2 dimensions. In this set of notes we're going to talk about what happens when we don't have perfect right angles. So in this scenario, Jill hikes 100 meters at an angle 40 degrees north of east, so that's going to be 40 degrees right here, and then stops and hikes another 400 meters at 15 degrees north of east. And so when we look at this, the problem that we have is there's no right angle that we have for the overall resultant, because the resultant is going to be approximately that, and these shapes don't give us a right triangle in and of itself. So we need to find another way to do that, and it can be done, but we're going to need to look at each of these displacements individually and break them into their components, and then we can add those components together. So that's going to look something like this. So these are the steps of how we would kind of walk through here, 1 through 6 over here, and we'll do this together. But hopefully what you can see in this picture is that our first vector here, this displacement 1, has 2 components. So we can break it into its individual components. It has this horizontal component right here that makes up displacement 1, and it has this vertical component right here. And so we call that y1. The second displacement has this right here. That's its horizontal component, so we'll call that x2. And then it has this vertical component, y2. And the key to this is recognizing that we can move vectors, right? So that's one of the properties that we talked about. This one goes over here, and this one can be thought of up here. But if we solve for them there, we can then put them and move them here, and that gives us overall one big right triangle. So if we know the total x displacement and the total y displacement from adding each of these components together, we get a right triangle that when we can use Pythagorean theorem to resolve for the resultant displacement. So let's try that. Okay, so here we have these. We are going to want to start by solving for x1, and then we need to put in the angle. So this is 40 degrees right here, and then y1 is over here, but I want to draw it here for these purposes. So this is y1 right here, and then we know that's 100 meters. So we have this displacement, we have the hypotenuse of our triangle, and we have the angle right there. So this is going to be the adjacent side, and this is our opposite side. So we're going to use trigonometry just like we've always done, and really I guess a better way to think of this is we have to solve 2 problems so that we can get our final answer. So x1, we are going to want to use, let's see, x1 is adjacent, right? So we'll just write them all. So toa. So if we want adjacent, we are going to use cosine. So we'll write this as cosine of theta is equal to adjacent, so that's x1 over displacement 1, right? And then we can use algebra. If we multiply both sides by displacement 1, we're going to end up with displacement 1 times the cosine of theta is equal to x1. So we'll be able to find that. So in this case, that is 100 meters times the cosine of 40 degrees is equal to x1. So x1 is equal to, when we put that in, cosine of 40 times 100, I end up with 76.6. So 76.6 meters is x1. So, because let's just do that same thing while we're over here, right? We'll solve for x2. So that's x2. I've just drawn it up here, and then I'll move it down there later. So x2 is going to be, we're going to do the exact same thing, right? I mean, this is now 15 degrees, but the formula we're going to use is the same. Displacement 2 times the cosine of angle 2 is going to equal x2. So displacement 2 times the cosine of theta 2 is equal to x2. So in this case, it's 400 meters times cosine of 15 degrees. So x2 is equal to, when I put that in, cosine of 15 times 400, I end up with 386. If I'm staying 3 sig figs, 386 meters. Okay, so I should write these somewhere here. So x1 is equal to 76.6 meters. X2 is equal to 386 meters. And so those two together will give me x. If I add those, I end up with x total. And that, so x total is going to be this entire, this is x total, right? The entire horizontal displacement. So 386, 86 plus 76.6 gives me 463. So the total x displacement on this hike is 463 meters. Okay. And so now I just need to do that same exact thing, except I want to do it for the vertical components, right? So if I erase all this, give myself a little space to work, I can get back out my pen, and y1, so now y1 is opposite of my angle. So I'm going to do the same thing. Sine of theta 1 is equal to y1, because it's the opposite, divided by d1. Multiply both sides by d1, so I'm just using algebra here, and y1 will be equal to displacement 1 times the sine of theta 1. So in this case, 100 meters times the sine of 40 degrees. So y1 is equal to sine of 40 times 100. And this is probably a good point. We've already should have done it before we started doing cosines and the x components, but is our calculator in degrees, right? So I checked before, mine is, so I end up with 64.3 meters. So y1 is 64.3 meters. And then I want to do the same thing over here, except I'm going to want that for y2. So I'll use this equation again, except y2. So y2 is equal to d2 times the sine of theta 2. So y2 is equal to 400 meters times the sine of 15 degrees. So if I put that in my calculator, sine of 15 degrees times 400 is equal to 104 meters. So y2, this component right here, y2 is 104 meters. So then I'm just going to do the same that I did here with x. I add them together because I'm looking for this total y component, right? Y total, and y total is just y1 plus y2. So y1 is 64.3. So 64.3 plus 104. I'm going to end up with y total. Y total is equal to 168 meters. So what we have is that this, let's just erase all this actually. That's gone. That's gone. And so now our components are solved for, right? So we don't actually even need any of this. We can get rid of all of this because we've seen how those add up to give us our totals. So now we can think of this as x total, right? And y total. And we have those values. So y total, this side of the triangle is 168 meters, and this side of the triangle is equal to 463 meters. And now this is a right triangle. So since I'm looking for this resultant, I can use those two sides of the triangle to find D. So we know that this is going to be theta, that this is theta total, right, our total angle, and this is our displacement total. So we're going to use Pythagorean theorem, right? A squared plus b squared is equal to c squared, where this is x total squared plus y total squared is equal to d total squared. So square root both sides, all of this, whoops. So d total is equal to the square root of 463 meters squared plus 168 meters squared. So if I punch that in my calculator, I end up with, keeping 3 sig figs, I end up that d total, the total displacement on this hike, is 493 meters. So even though they did 100 meters and 400, their total displacement is 493 meters. And then I need to solve for this angle. And so really there's many ways that I can do this because I have all sides of the triangle. So I could really use any of these trigonometric functions. I'll just stick with inverse tangent since that's what we've done. So the total angle is going to be equal to the inverse tangent of, this is opposite, so y total divided by adjacent x total. So in this case, the inverse tangent of y total, so that's 168 divided by 463, and then I'm going to take the inverse tangent of that, and I end up with theta, sorry, just put those in, 168 meters over 463 meters. My meters cancel, so that's good. I have no unit. So theta total is equal to, I end up with 19.9 degrees, and now we need to give it a direction. That's 19.9 degrees. I went that way, so I went north of east. So to review, when we have no right angles, we have to make right angles, or we can make right angles out of the individual components that we're given. And then we can use those to solve for the total horizontal displacement, or excuse me, the total horizontal vector, because it doesn't always need to be displacement, right? It could be acceleration or velocity, or later on we're going to look at force. So we add the component horizontal vectors together to solve for the total horizontal vector and the total vertical vector. Use those and the fact that they will make a right triangle to solve for the total. Something to just caution you here. In this problem, both of my horizontal vectors were positive because they were to the right, and both of my vertical vectors were positive because they were to the north. But a situation will and can occur where one of these horizontal components could be north and the other could be south. So it's important to keep track of your signs, because then we'd be adding y total would be plus some number and then minus some number. So be on the lookout for those as you solve your practice problems and think through these. I hope this helps.